There are three things certain in this world. 1. The Earth makes one complete rotation every 24 hours. 2. The Earth revolves around the Sun every 365 days. And 3. The Sun makes one complete revolution around the Milky Way every 226 million years. Today, I'm going to be talking about suns. No, I don't mean a boy descendant that makes your life much more tougher. I'm talking about suns, as in the fiery ball constantly undergoing fusion of hydrogen and helium that you see in the sky from 12 to 9. Our solar system is rare. It is one of the few that operates on only one sun. Most solar systems have a binary star system. Imagine waking up one morning and seeing two suns in the sky instead of one. That really would be something, wouldn't it? Our sun, and 90% of all other known stars, are categorized as main sequence. This means it has reached a stable, relatively long-term balance between the competing forces, fusion outward and gravity inward, and has enough energy to sustain the balance. Unfortunately, our sun is not always destined to be a main sequence star. It will expand into a red giant after the main sequence and start fusing helium into carbon and oxygen. Eventually, the reaction inside the star will become unstable and it will throw off the outer layers, leaving only an extremely hot core in its place, called the white dwarf. Thank goodness we'll be dead before this apocalypse. Red giants and supergiants. No, I'm not referring to a monstrous creature that you'll see in some lame PG-13 movie, are some of the biggest stars in our solar system. Although not very hot, they can reach tremendous sizes. They have a high luminosity due to their large size, but as mentioned before, a relatively low temperature, which is apparent from their reddish glow. White dwarfs, which our sun is one day destined to become, are small and have relatively low luminosity. Their white color tells us that they're relatively hot. Unlike the sun, which is composed of hydrogen and helium, white dwarfs are made up of oxygen and carbon. Cepheid stars are the most interesting of them all. They have a luminosity that changes periodically over time, depending on its location. But they don't only change in their luminosity, they also grow and shrink in size. A blue giant, and again no, not a monstrous creature that you'll read in some lame horror novel, is the category of stars that has the least amount of stars. To be honest, they're very much like red supergiants, except they're slightly more bigger, have a higher luminosity, and hot enough to be called blue. The Hertzsprung-Russell diagram contains all these types of stars, along with their luminosity relative to the sun, spectral class O, B, A, F, G, K, M, absolute magnitude, and of course their temperature.